Let's have a look at logarithm law number 2 now. Now we've looked at number 1 already, where if you have a product of two numbers and you take the logarithm of that product, that could be split up as a sum of two logarithms. Logarithm law number 2 is actually related to index law number 2, where if you're dividing two terms or two numbers and you take the logarithm of those two numbers, it can be expressed as a difference of two separate logarithms of the individual numbers involved. As an example, if we have, say, log of base 10 of 10,000 over 100, and I've chosen something fairly easy to comprehend. 10,000 over 100 is 100. Log base 10 of 100 would be 2, because 10 to the power of 2 would be 100. Does it work here? The difference of two logs. Log base 10 of 10,000 is 4. Actually, I might just write that down there. That's 4. Log base 10 of 100 is 2. And log base 10 of 10,000 over 100, which is 100, log base 10 of 100 is also 2. So 2 is equal to 4 minus 2. That holds true, at least for this example. Let's now prove it, though, for any values. Okay, so let's... Now, probably at this point, I would invite you to pause the video, see if you can prove it for yourself. So you might want to have a look at logarithm law number 1, look at how that's been proved, and see if you can apply the same basic proof to logarithm law number 2. Okay, so anyways, let's begin. So again, we're going to do the same basic thing. So we're going to say, let's define two pronumerals, and we'll define pronumeral x as the exponential a to the power of n, and this other pronumeral a, okay, so y, expressed as a to the power of n. Okay, so a to the power of m, a to the power of n. Okay, so it's going to look very similar, in fact. Now, if x is equal to a to the power of m, then we could write it in logarithm form. Log a to the x is equal to m. Okay, after all, a to the power of m is equal to x. Okay, so it's very important that we start to train ourselves how to interpret or how to read a logarithm. Okay, or something expressed in logarithmic form. So y equals a to the power of n. That could be expressed as log of base a, or log base a of y is equal to n. After all, a to the power of n is equal to y. Okay, now instead of a product, we're going to have a quotient. So x over y, okay, is equal to a to the power of m divided by a to the power of n. Okay, and the second index law states that if you're dividing two terms with the same base, you subtract the indices. Okay, so just to maybe save a little bit of space, I'm just going to continue it over here. So x to the power of y, okay, just clear a bit of space, sorry. X to the power of y is equal to a to the power of m minus n. Okay. Now, if we express this expression here in logarithm form, what do we have? So x on y is just a number. So just think of it as it's just a value. Okay. So log, if x on y is a to the power of m minus n is the index. In other words, log of something is going to equal m minus n, isn't it? Right? Okay. Remember that the result of a logarithm is an index. So the index here is m minus n, and log base a of x over y is equal to m minus n. But we have a definition for m and a definition for n. The definition of m is log base a of x. Okay. And the definition of n is log base a of y. Okay. And I might just complete the proof by completing the left-hand side. Therefore, log base a of x over y is equal to log base a of x minus log base a of y.